So I just ran a lab here in my kitchen and I'm very excited because it looks like my data is very good. Now I'm going to upload this data table for you, and but let me just explain what I did, and then I'll upload pictures of the data, and then I'll explain to you how we use the numbers in the data to actually make our calculations. Now this is a Charles Law lab, and Charles Law states that as volume increases, temperature increases, and as volume decreases, temperature decreases. The big thing that we have to be careful with, though, is when we do any of these gas law labs and we're talking about temperature, we have to convert to Kelvin. The reason is because there are no negative kelvins. The equations don't work if you don't convert to kelvins. All right, so in this first beaker here, I set the plunger at 20, and I held it in ice water for 3 minutes. At the end of 3 minutes, I pushed the plunger in, pulled the plunger out, and I took 2 readings. Then I did that, of course, the whole time I had my thermometer in there. My thermometer was giving me a reading. Then I went to room temperature water and I did the same thing. Of course, these were fuller. I was mixing water as I went. And once again, I held it for 3 minutes. And then at the end of the 3 minutes, I pushed my plunger in and got a reading. Checked the temperature, recorded that, pulled my plunger out and released and got a reading, checked my temperature and recorded that. I did that for 40, I did that for 60, and when I got to 80, I got smarter and put it in one of these cups that hold their temperature nicely. I was scared that the 80-degree water would crack one of my glasses. And so when I got to 80, it held the temperature a lot better, so probably this is my most accurate data from the whole lab. Okay, once again, I held my syringe underwater in 80-degree water. At the end of the 3 minutes, I pushed the plunger in, I pulled the plunger out, I took my readings again. And then this is the data that I got right here, and we're going to talk about that data right now. So here's a series of pictures just to show you my setup. This is my 0 degrees Celsius reading, 20 degrees Celsius, 40 degrees Celsius, and you notice the temperature was falling. So my target was 40 or 20, but the temperature was falling. Here's 60, and more with 60, and then 80. And that's why you have your target temperature, but then you have your actual temperature, and you can see those recorded in my data table. Go ahead and copy these into your data table. Pause the video, take the time, and copy these values down. Now, before we proceed with playing with the data, let's just make sure we understand what happened. When I put my syringe into 0-degree water, well, actually my water was only at 6 degrees, my volume was about 18.5 or 19. Notice what happened to my volumes as my temperature increased. As my temperature increases, my volume is also increasing. Now remember that when you read about Charles' law, it says that as volume increases, temperature increases. So this is what we expected to happen, and this is what indeed did happen. So Charles' law is a direct relationship. So before you start manipulating the data, just make sure that you understand that the data already supports the law, because as temperature is increasing, volume is also increasing. So we just collected data by submerging a syringe in water. And remember, we submerged the water in the target temperatures were 0 degrees, 20 degrees, 40 degrees, 60 degrees, and 80 degrees. Now those were our target temperatures. It's impossible for me with my cups here at my house to keep it exactly at that temperature, but that doesn't matter, provided when we record our volume, we record the actual temperature it is. So this is the data that we collected. And these were the actual temperatures. Remember, this is my target temperature. These were the actual temperatures I recorded, and you can see where it says plunger in and plunger out, and you saw me push the plunger in and take a reading and pull the plunger out and take a reading. And the reason why I did that was to try and come up with a way to overcome friction, because of course the syringe is under friction, and even though I try to lubricate it well, there's still enough friction that could mess with our data. Now I'm going to walk you through how to calculate the values for 0 and 20, and then your assignment is to complete the data for the rest of the table, and then we'll come back tomorrow and we'll talk about it. Okay, so what are you going to do? First of all, we want the average actual temperature. Well, you can see that I had 6.0 and 6.0, so my average actual temperature was 6.0. And then I have to convert to Kelvin. Now, we're not going to worry about sig figs to the very end, and then we're going to do all our answers to 2 sig figs to have continuity, okay? So my actual temperature was 6.0. If I want to convert that to Kelvin, I say 6.0 plus 273.15. And I am going to get 279. 273 plus 6, 279.15, or just 279. So let's go ahead and put 279 in there. And then let's go ahead and add the 0.15, even though we're not obeying sig fig. So that's 279.15 Kelvin. Then this value right here, we want our average volume. Our average volume is going to be the average between 18.5 and 19.0. Our average is going to then be 18.75. And now I'm going to calculate V over T. So I'm going to say 18.75 divided by 279.15. 18.75 divided by 279.15. And when I do that to 2 sig figs, I'm going to get 0.067. So that's the ratio of my volume to my temperature. Okay, so let's now try and do the next one together, and then I'm going to leave you to do the rest of them by yourself, okay? All right, so the next one, at the end of the 3 minutes, when I pushed my plunger in, my temperature was 25.6. When I pulled the plunger out, my temperature was 25.7. My first volume was 19.5, the plunger in value. The plunger out value is 20.0. So now what I need to do is I need to find the averages of these values. When I find the averages of these values for the temperature, I'm going to get 25.65 degrees Celsius. I'm going to make this a bit bigger. 25.65 degrees Celsius, and then I have to convert that to Kelvin. Well, how do I convert 25.65 to Kelvin? I'm going to say 25.65 plus 273.15, and when I do that, I get 298.8 Kelvin. Okay, now I need to find the average of my 2 volumes. I need to find the average of this volume and that volume, and if I say 19.5 plus 20 divided by 2, I'm going to get 19.75. So now I have my volume over my temperature. My volume is 19.75. My temperature is 298.8. When I divide that and round to 2 sig figs, I'm going to get 0.066. And already I feel pretty proud. Why? Because these numbers are very, very similar. Now I'm going to leave the rest of this data with you. I will upload this to your pages, or you can just copy it directly. And I want you to complete and upload this table for your assignment today. And then tomorrow we'll talk about the data.